Hello students, already I have uploaded some important question and solutions of vector calculus, and this is the most important part of vector calculus, which is Green's theorem. So you have to know the statement very well that Green's theorem is, suppose C be a simple closed curve in R2 that is piecewise smooth and positively oriented, that is counterclockwise, and let D be the region bounded by C. Suppose P and Q are function of x and y defined on an open region containing D with continuous partial derivative. Then Green's theorem stated that the line integration P dx plus Q dy is equal to the double integration del Q del x minus del P del y dx dy. So this is the statement of Green's theorem. You have to know this very well because there will be so many MCQs from this part. And also this statement you can write in vector form. What is that? That is, you also can write this in terms of vector, that is line integration of f dot dr equals to double integration curl of f dot k cap dA, where A is for area and f is pi plus qj vector. Do you want to know why we can write these two as same? Because if f is pi plus qj, then and r is, already we know that r is xi plus yj plus zk, the position vector, then dr will be component wise derivative dxi plus dyj plus dzk. Then if you calculate f dot dr, then we have p dx component wise multiplication, so p dx plus q dy plus z dz, but since z portion is 0 in this case, then it will be 0, so only p dx plus q dy. Hence we obtain the LHS, that is line integration of p dx plus q dy. Now let us calculate curl of f. So we know the formula for curl is ijk del x del y del z, and f is pi plus qj, so p, q and 0. Now we have to expand the determinant, so I into, we have to multiply corner wise, but see here p and q are function of x and y. So whenever we will be derive with respect to z, del q del z will be 0, and similarly minus I 0 minus 0 plus k del q del x minus del p del y. So the curl of f is k cap del q del x minus del p del y. Now we have to take the dot product of curl of f with k dot dA. Then if we take dot product with k, then only del q del x minus del p del y will be left with us, and dA is dx dy. So we are getting the RHS. Hence we can write this p dx plus q dy in the vector form. So these two are equivalent. Now there are some particular questions from Green's theorem. First one is verify Green's theorem, and second one is using Green's theorem you have to solve line integration or double integration. So let us move to some question. This is a question of verify Green's theorem. So here f is given in this vector form, where the curve C is bounded by y equal to x and y equal to x square curve. Or this question may come in another form, that is in the integration form, that is line integration xy plus y square dx plus x square dy. So these two are same. Now we know that, because if we do f dot dr, then we will be getting this part. So let's start the solution. So since verify Green's theorem, that means we have to calculate both the line integration LHS and the RHS, that is the double integration. And if those two will be same, then we can say Green's theorem is verified. So let's move to the solution. So we have to show that the left hand side line integration over C xy plus y square dx plus x square dy, which will be equals to the right hand side double integration del q del x minus del p del y dx dy, where p is the function xy plus y square, function of xy, and q is the function x square. So if these two are same, then we can say that Green's theorem is verified. Or since if you have the question in vector form, then you can write that, or you can write the line integration f dot dr form, that is the right hand side will be curl of f with k dot dA. So if the question is in vector form, then you can write in the vector term. So the LHS is line integration xy plus y square dx plus x square dy, where the curve C is bounded by y equal to x and x square equal to y. So y equal to x is the line passing through origin, and x square equal to y is the parabola which is upward. So this is y equal to x and this is x square equal to y. Now C is the curve bounded by these two curve. So when we have to calculate the line integration, if you know the line integration how to solve, then this is very easy for you. Or if you don't know, then you can check the previous lecture video. So we now can divide this C into two parts. First one is C1 and second one is C2. What is C1? C1 is, okay, first we have to find the point of intersection. Then we can solve y equal to x and y equal to x square. And solving these two, we are getting x equal to 0 and x equal to 1. If x equal to 0, then y equal to 0. So one point of intersection is 0, 0. Let us give the name O0, 0. And another point is 1, 1. So what is C1? C1 is the line OA and C2 is the line A to O. We have to solve these two integration now. So for C1, that is for O to A, the equation of the curve is y equal to x square, that is dy equal to 2x dx. And in this case, x going from 0 to 1. Hence, for C1, if we substitute the values, then we can write the integration over C1 will be x cube plus, if we put the value, then x to the power 4 plus this is x square and dy is 2x dx. So calculating, we are getting, and x going from 0 to 1. So calculating, we are getting integration 0 to 1 3x cube plus x to the power 4 dx. And if you calculate this, then 3 by 4 x to the power 4 plus x to the power 5 by 5, and the limits 0 to 1. So after substituting the limits, 3 by 4 plus 1 by 5, that is LCM is 20, and then 15 plus 4. So the final answer is for C1 is 19 by 20. Now we have to solve for C2, and what is C2? A to O, that is along the line y equal to x. So if you want to solve along C2 or A to O, then the integration is this, and along A to O the equation of the line is, along C2 equation of the line is y equal to x and then dy equal to dx, and x will be going from 1 to 0 because we are going from A to O. So integration, if we put the values y equal to x and dy equal to dx, it will be 2x square dx plus y square, not y square, this is x square dx, and x equal to 1 to 0. Then 3 into x cube by 3, 1 to 0. So it is minus 1. Now the final line integration over C is equal to sum of the line integration over C1 and C2. So the final integration will be 19 by 20 minus 1, that is minus 1 by 20. And now we have to calculate the RHS. So for RHS, P equal to xy plus y square and Q equal to x square. So we have to calculate now del Q del x minus del P del y. Then it is 2x minus x minus 2y. Hence x minus 2y. So now we have to calculate double integration x minus 2y then dx dy. This is our right hand side. And only thing is left to find the limits. So to find the limit, we know that this shaded region is the D. And you know how to solve double integration. We just taken an vertical strip, and then the lower curve of the strip is lower limit and the upper curve of the strip is upper limit. So y equal to x squared to x. If you don't know how to solve the double integration, you may check previous videos. So y equal to x squared to x and x equal to 0 to 1. And then if you solve, this will be integration 0 to 1. And if you put the limit for y equal to x and x square, then it will be x minus x square minus x cube plus x to the power 4 dx. X square and minus x square will be cancel out. And then finally minus x to the power 4 by 4 plus x to the power 5 by 5. So this will be 0 to 1, and if you put the values, then minus 1 by 4 plus 1 by 5. So this is 4 minus 5 plus 4 equal to minus 1 by 20. So LHS is minus 1 by 20, RHS is also minus 1 by 20. Hence the left hand side is equal to right hand side equal to minus 1 by 20. That is Green's theorem is verified. Okay. Now let us move to the second question. So first question was verification of Green's theorem, and this question is we have to use Green's theorem to evaluate this line integration. So let us move to the solution. Since C is positively oriented boundary, so we can use Green's theorem here. And if you check, P equal to minus y by x square plus y square and Q equal to x by x square plus y square. So we will be using Green's theorem. Then we will be transferring the line integration to the double integration. So since P is this and Q is that, then we have to calculate del P del y, which is x square plus y square whole square, and then x square plus y square minus outside, and in this case plus y into 2y. So that is y square minus x square, and denominator is x square plus y square whole square. And also you have to calculate del q del x. Similarly, x square plus y square power whole square is the denominator, and x square plus y square into 1 minus x into 2x, that is y square minus x square by x square plus y square power whole square. So, by Green's theorem, line integration p dx plus q dy is equal to double integration del q del x minus del p del y and then dx dy, where the double integration over D region and line integration over C. Now you can see that del Q del X and del P del Y are same. So if we subtract, then this will be 0. So the final answer is 0. Now you can see that we do not need to draw the region. So Green's theorem is very useful to solve this type of question. Next question is, we have to prove that this line integration equal to 0 where C is the circle x square plus y square in the xy plane described in the positive sense. Hence, we can use Green's theorem here, and since p dx plus q dy is the formula, so comparing we can get p equal to cos x sin y minus xy and q equal to sin x cos y. Now del p del y is equal to cos x cos y minus x and del q del x is equal to cos x cos y. Then del q del x minus del p del y is equals to this minus that, so it will be x. Now by Green's theorem we know that we have to solve the double integration, because Green's theorem stated that if line integration p dx plus q dy, then it will be equal to double integration del q del x minus del p del y dx dy. Hence x dx dy. Now let us draw the region in this case. So since given that x square plus y square equal to 1, that is unit circle, so radius is 1 and center is origin. So this is our region, and positive sense means counterclockwise. Now we have to calculate the double integration over this shaded region. So you know that how to solve double integration. We have to take a strip. You also may take horizontal strip, but I am taking here vertical strip. And the left end is minus 1 and the right end is 1 because radius is 1. So you know the limit. So the limit will be y equal to minus root over 1 minus x square to 1 minus x square. And the limit for x is minus 1 to 1, because the strip is movable from the left end to right end. And hence, if you calculate the integration, it is xy and then y equal to minus lower limit to upper limit dx. Then minus 1 to 1, it is x square root of 1 minus x square plus the same. So it will be 2 square root of 1 minus x square into x dx. Now this x into square root of 1 minus x square, this is a odd function. Since this is a odd function, you know that the integration will be 0 because it is from minus 1 to 1. Hence, we are done. So you can see that if you know how to find line integration or how to find double integration, then the problems for Green's theorem is very easy to calculate. It will be very easy for you.